Problem number 5.2. Find the basis and its dimension using given equations. Equation we have x1 minus 2x2 plus x3 plus x4 equals 0, and 2x1 minus 4x2 plus 2x3 plus 2x4 equals 0 when the system is homogeneous. We have to find basis and its dimension. As the system is homogeneous, so we write given equation in the matrix form. 1 minus 2 1 and 1, 2 minus 4 2 and 2, and variables are x1, x2, x3 and x4, which will be equal to 0 and 0. As it's a ax is equal to 0 form, applying operation because we have to get rank of A as to solve homogeneous system. Ax is equal to 0 from the necessary condition is rank of necessary condition is rank should be less than number of variables. So applying operation will be R2 row 2 minus 2 row 1. It will be 1 minus 2 1 1 and 0 0 0 and 0. So we get x1, x2, x3 and x4 equals 0 0 as one non-zero row and 1 0 row. Here number of non-zero row in A is 1. So rank of A is 1, and we have number of variables as 4, which is x1, x2, x3 and x4. Nullity is equal to 4 minus 1, and free variable will be 3. So equations are only 1. So we have one equation with the help of non-zero row, which will be x1 minus 2x2 plus x3 plus x4 equals 0, which becomes equation 1. So we have one equation and 4 variables, out of which 3 are free variable. We can take any 3. So let us take x1 is equal to k, and x2 is equal to t, and x3 is equal to s. You can take, we can take anything, lambda 1, lambda 2, lambda 3, likewise. Here we have taken kt and s, so we get as k minus 2t plus s plus x4 is equal to 0. It will be x4 equals to minus k minus s plus 2t, x1 is equal to k, x2 is equal to t, and x3 is equal to s. Now x4 is equal to minus k minus s and plus 2t. Solution vector can be written as x1, x2, x3, x4 equals to k, t, s, and x4 is minus k minus s plus 2t. Now we write this solution vector in the form of x1, x2, x3, x4. We are separating coefficients k, t, s minus k minus s plus 2t, which will be equal to so we have k as 1 and we have no k here, then it will become 0. Here has no k, it will be 0, and here has minus 1. So now we separate t, no t, so 0, 1t, and no t, 0, and we have here 2. So it will be plus s. Here we have no s, 0, 0, and 1s, and here we have minus 1. What we have done here, these are the coefficients of k, t, and s. Now we have 3 column vectors, and all these column vectors are developed by free variables. Now we have 3 column vectors, and all these column vectors are developed by free variables k, t, and s. Now the basis is nothing but, we get basis as basis 1, 0, 0, and minus 1, and second one is 0, 1, 0, 2, and finally third one is 0, 0, 1, and minus 1. So these are vectors in set. This is first, this is second, and this is third vector in set. So all these column vectors are linearly independent. So this is answer. Now we start with summary. Now summary will be, So this basis is consisting only three independent vectors. We see in each vector how many component we have. We have four components. Like we have four components. This is first, this is second, third, and this is fourth. First, second, third, fourth. First, second, third, fourth. We have four components in each vector. That's why we have to understand vector space is r power 4, but we have only three independent vector in our basis. That's why we can say that this is subspace. This is subspace, not spanned. Like it won't span. It will give only subspace of our vector space. In the previous problem, vector space is r power 3. Basis is also consisting three independent vector for r power 3. That's why we can say that it spanned r power 3. In this problem we have three vectors dimension 4. Let me show you. This is first, this is second, and this is third vector. Dimension first, second, third, and fourth. In each vector we have 4 dimension. Our our vector space is of dimension 4, but we have only 3 independent vector. That's why it is only subspace. So each vector has 4 component. 4 component means we require 4 independent vectors, but here we have only 3 independent vectors. This is first vector, this is second, and this is third vector in a set which is subspace of r power 4. So which is a subspace of r power 4. So finally it is only and only subspace. If it had 4 vectors, then we could have said it spanned.